Let's start, right? Okay, so I want us to form a number, okay, with different digits, okay. I'll pick just a few people to give me some digits. I'm not going to think of this number. And then we decide, okay, how many significant figures are there, okay. So it can be a decimal, it can also be a whole number, okay. This person shall first decide, Melissa. Okay, do you want it to be a decimal or a whole number? Sorry? Whole number, huh? Okay. So now we're looking at a whole number, okay, then Joe can give us the first digit to this whole number. Sorry? 7. Okay. Then after that, next digit, Trixie. 4. Okay. Ethan. 6. Okay. Jun Jun. 2. Okay. Next one, 3 now. 3. Okay. No zeros. Okay. This next person you can decide now if you want to put a decimal point or not. Okay, and change what Alyssa has decided. Alright? So Brandon. Okay, I know that you didn't come to lesson, but just give us a digit. It can be anything from 0 to 9. Okay, or if you want to give me a decimal place also can. You want to give a decimal place? Okay, sure. Let's put a decimal place here. Decimal point. Okay, then next digit. Actually is not here. Alright, let's see. 0, okay. And then Hansheng. 8. Okay. Next one, Inkin. 5. Okay. And then this shall be the last 3 digits, okay? Rose. 0. Okay. Evan. 0. Okay. One more last digit. Okay. Xavier. 9. Okay. Right. Now, how many significant figures are there in this number? Okay. Let's choose one person to think. Faith. How many significant figures are there in this number? 7. How do you count 7? It's lost in how you count 7. How do you count? How many significant figures are there? Now you say 11. You say you want to go to 7-11. So there are 11 significant figures. Okay. So maybe it's a very quick recap for Brenda who joined us today, right? Okay. For significant figures, okay, essentially we're looking at what are the important number of digits in the number itself. Okay. So we do a quick check. Faith says that there are 11 significant figures. So we know that this whole number portion, okay, these are the digits that we need to count. So there's 1, 2, 3, 4, 5. Okay, so there are 5 significant figures over here. For the decimal portion, we will also have to count every single thing because there are always non-zero whole numbers inside it. Okay, sorry, non-zero digits. So 5 over here, 6, 7, 8, 9, 10, 11. So there are a total of 11 significant figures in this number. Okay? We write this down first. Alright, yes, Xavier. Okay? Add a 0 behind the 9, is it? Oh, okay. Change the 9 to a 0. So, as a proposal, a suggestion, to change the 9 to a 0, okay? Which is what I wanted to ask also, actually. So, someone has been reading my mind, I guess. Okay, so for this number, how many significant figures are there? Okay? So, Francis. Francis, what you want to speak? You put out the basket, right? 8. 8, okay? So, let's count. Okay, so how do you do the 8? Is it this one is the first significant figure? Okay, 1, 2, 3, 4, 5, 6, 7, 8, is it? Then the remaining zeros not counted. Okay? Who agrees with Francis? Okay? Who disagrees with Francis? Okay, so I think we're a little bit half-half over here. Okay? So recall that, okay, the last minimally, okay, or decimal, okay, I intentionally put zeros, that means they are actually important, okay. So therefore, these zeros we must count. So there should actually be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 significant figures as well. Okay, there should actually be 11 significant figures. Alright, question 6.
So the question didn't say leave the answer like 1, 2, 3, 4, 5, 6. There's no place. It will be 8 significant figures.
Okay, so now this is a decimal number. Okay, for decimal numbers, the zeros that come at the back, because they appear there, okay, we must count them in. Okay, it is only if it is a whole number. Now what if, okay, I have a whole number now, like that. Okay, how many significant figures would there be then? Okay, so this was the part that was tricky, okay, in our last lesson. We know that this one we must count. Okay, you start counting 1, 2, 3, 4, 5, 6, 7, 8. Now this zero must be counted because it appears in between two non-zero digits. Okay, so minimally all these digits over here must be counted. So 8 digits must be counted. But this is a whole number. The zeros at the back, okay, will actually then depend on the situation already. Okay, so depends on whether the question say round off to the nearest 10, for example. Okay, let's say this number was rounded off to the nearest 10. 10's position is actually over here. That means that I will count from 8, 9, 10. Okay, so nearest 10 will be in 10 significant figures. Okay, if the question says to the nearest maybe ones, okay, or nearest whole number, they mean the same thing, yeah? Okay, so this was rounded off after, okay, so this is the resultant now, okay, so therefore we will need to then count up to this zero over here, and that will make it 11 significant figures, okay, and then if let's say the question wants us to round it to the nearest hundreds, the hundreds place will actually be here. How many significant figures will there be then? Colin, you want to try? If the question say round to nearest 100 place is here, right? Nice significant figures, great. Okay. Okay, and then if let's say in this question, right, actually this one is the minimally must be counted, so the at most, okay, can only be rounded to nearest 1000, okay, and that will give us 8 significant figures. Okay, so only in the whole number itself, alright, we need to take into account what is the context the question has mentioned, what was it rounded off from, okay. Then we will have 8 significant figures all the way to 11 significant figures. Okay, so there are many different possible answers. So whole numbers, we must read the question carefully. So that was rule number 5. You understand? Okay. So I hope that this is a very quick recap about our significant figures rules. Okay. Okay. Now let's go back to where we left off in the last lesson. We were looking at 3.1, rounding and significant figures. Okay, let's take a look at your practice down 3. In the last lesson, we only touched on question 1A and 1B. So let's continue to look at 1C and D today. Okay. So we have the number Okay, so in our number 4971, 2 will mean that I only want my 4, I only want the 9. Okay, so that means that we stop over here, we look at the number on the right. Okay, 7 will cause our 9 to round down or round up. Round up, right? Okay, so that means that our 9 will be rounded up into 10. So our answer will have to become 5 over here, 0. Alright, but then we must actually have additional zeros to hold the place for this number. So we need to add in, okay, another 2 more zeros. So when rounded off to 2 significant figures, it will actually be 5,000. Okay, so 4971 equals to 5,000 after rounding off to 2SF. Okay, you need to actually indicate what is the rounding, so you must put bracket 2SF. Okay. Okay, for part B, we want to round off to 2SF as well as 3SF. So let's do rounding off to 2SF first. Okay. So in this decimal number, okay, just now that we have not yet covered is what if you start with zeros. Okay, in the decimal number, if it starts with 0, are these zeros significant? Yes or no? Who will say these zeros are significant? Who says these zeros are not significant? Okay, good. So in this case, decimal place, these zeros that we start off with, we don't count them. So we first count from this one, this number 9 over here. That is our first significant figure, second significant figure. Okay, looking at the digit on the right, which is a 9 as well, it will cause my 9 to round up to become a 10. But when I have it to become a 10, my 9 must also plus another 1. Okay, so it will have to round up, okay, such that this 0 becomes a 1. So 0.09999. When rounded off to 2 significant figures, I will have 0.10. Okay? This definitely is counted as 2 significant figures because I will start counting my first SF from 1 and then second one and the next 0. Okay, so this is the 2SF answer. Okay? Then, what if in this same question, they also ask to round off to 3SF? Okay, so with the number 0.09999, okay, you want to round off to 3 significant figures. We start counting from here. 1, 2, 3. Looking at the next one, it is a 9 as well. Okay, so we will have to round up. All my 9s will have to add in another 1. Okay, so therefore, when rounded off 3 significant figures, I will get 0.100. This is 3SF. Okay. Any questions? Alright, next we look at question 2. Okay, let me write down the question first. Please read what's on your textbook. Okay, question 2 says that the number of people at a concert is stated as 21,200. That is after correcting to 3SM. Okay, so this number is 3 significant figures. Okay, the question asks what is the largest and the smallest possible number of people at the concert itself. Okay, so that means that there is a number, okay, before we rounded it off into 21,200 3SM. Okay, and the way we count 3SM out of this number is that we have this, and this as my 3 significant figures. Okay, so before getting 21,200, surely there must be a 2 and 1 over here. Okay, so before that it must have either been rounded up or rounded down to get my 21,200. So there are 2 possibilities. Okay, one process which is rounded up, another one which is round down. Okay, so 2 separate cases. Alright, let's first look at the round up case. Okay, what must this number be, okay, before 21,200 in order to be rounded up to get me 21,200? What must this digit over here be? Are you following what I'm saying? Yes, let's see. 1. Okay, so this digit must have been a 1 in order to be rounded up to be here, alright? Okay, it cannot be a 2. Alright, so the digit over here, what are the possibilities that will cause my 1 to round up to become a 2? Okay, Joshua. 5. Any other digits?
6, 7.
Okay, good. So 5, 6, 7, 8, 9. Okay, so there are all these possibilities. The last space over here, okay, it can be anything, it doesn't quite matter. Okay, so we must have this understanding first. Then let's look at the rounding down. Okay, what must this space actually be, alright, in order for us to round down to get 21,200? Zach, what do you think? What must this digit actually be? Yes. What must this digit over here be? For me to round down to get 21,200.
4.
Huh? 4? You say 4? 21,000 something. Then after that get 21,200. This digit must be what?
2.
2. Why? Because Faith tell you the answer. And then because you are so engrossed in talking to Trina. Okay, next time pay attention, okay? So over here, alright, should actually be a 2, alright, because you're looking at rounding down, okay? In order to round down to achieve here, the digits over here must actually be what, Joel? What will cause my 2 to be rounded down to a 2? 1, 2, 3, 4, anything else? One more. Okay, let me write down what you have to me now. 1, 2, 3, 4. 1, 2, 3, 4, 5, 7, 8, 9 is over here already. One more digit. Say again? 0, yes. Okay? So 0, 1, 2, 3, 4 will cause, okay, my 2 to be rounded down to get this one. Okay? The last spacing likewise can be any digit, it doesn't quite matter. Okay, so now we have settled these cases. We go back to answer the question. Question wants us to find the largest and the smallest. Okay, so largest possible will have to come from this case here because this is 21,200 something. Whereas over here is 21,100 something. Okay, so since I'm trying to get the largest possible in this case, this space over here, which one digit should I choose? 4. Okay, so we choose a 4. And then the last one, the one largest possible, we choose a 9. Okay, so largest possible will be 21,249. possible. Right? Smallest possible will come from here. Okay? So Singru, can you tell me what you think is the smallest possible? 21,105, is it? Okay? And then the last place, what will you put? What is the last digit you put? 0. Okay? So our answer will be 21,100. Okay? Questions? Okay, why don't you take a look at textbook page 79. Okay, so let's look at this one. It says that the number 21x09, we don't know what is x, is actually equal to 22,000 after it's been rounded off two significant figures. So with 21x09, if I want to round off 2sf, I will look at first, second digit. This x over here will influence the way we round up or down, okay, for the 1. But since I know it is going to be 22,000, it means that my process over here is a rounding up or rounding down process. It's a rounding up process, right? Okay, that will mean that my possible values of x okay, what are the possibility for my value of x? Okay, Xavier, hang on okay. Maybe let me just choose someone. Calling Joel already. Elena. Okay, can you tell me what are the possibilities for x? They will cause a rounding up. 5, 6, anything else? 7, 8, 9, great. Okay. Okay, so we recognize what are the possible values of x already. But then the question actually has another condition. It says that my number 21x09 must be a perfect square. Okay? So that means that with these digits, I'm looking at either 21509, 21609, 21709, 21809, 21909. Okay? How do we check which one is a perfect square? Kenny, what do you think? How do we check which one is a perfect square? What will you do to check which one is the perfect square? Square root, right? Okay. So what we can do, we just take square root of all these numbers. Okay, see which one will give us a whole number. So can you do a check now? Okay, which one will give us a whole number? 21609, is it? Okay. So we should find that 21609 gives us what? 147. Okay, the rest will give us about 146165, 147.33. that our x, so question asks us to find x, so x must be equals to 6. Questions? Okay, so that's it for your chapter 3.1. I would like us to do homework, okay, not do now, but then I want to give you the homework question. Exercise 3A, that's in your textbook, page 79. Question 2, 4, 6, 7, 8, 10, 11. Okay? Now this is a homework that I'm giving after a long period of time, because the last time we did was chapter 1. And then the way you submit to me your homework for chapter 1 was quite terrible. Okay, I want all of us to take out foolscap paper now. Okay, take out your foolscap paper. I want us to all be very clear about the format, okay, of answering your homework. Okay, so all take out foolscap paper. If you are using the swimming foolscap, write your name, class, index number, okay, all at the top right hand corner. Okay. Now question 2 in your homework, okay, so in your foolscap, okay, if you are using the school one, we have details that you've been doing over here. Okay, I want you to write there exercise 3A as the subject as well. Okay, or you can put math exercise 3A. Okay, for subject you can put math exercise 3A or just exercise 3A. Okay, the date today is 20th February, so you can fill in that also. Now question 2, there are a few parts. So if you have looked at your textbook, there is a 2A, B, C, D. Okay? So 44974.8 rounded to nearest 10. Okay? The question says this, alright, don't need you to write down the question in your homework. Okay, I need you to write the answer though. Okay, so we will write 44974.8. Okay, equals to, what is your answer? And then you put in nearest 10. Sorry, this foolscap that I have is too small. Okay, right? So that's the expectation. Okay, you can do your answer now. Put your own answer over here. Now, I want you to leave 1 line, then you go to part B. Okay, notice that my question number is all inside the margin. Okay? I know some of you don't have your foolscap. Okay, make sure that you just maybe take a note of this. When you submit to me your homework, make sure that it is clear. Okay? Alright? Actually, you don't need to underline. I'm just writing this underline so that you know your answer is supposed to be here. So you just write answer there. Okay, then after part B, it should be another 44974.8. Then your answer, and then I think the question asks for nearest 100. Okay, so this is the expectation. Every single line, new answer you give me 1 line of spacing, then you go to part C. Okay, I do not want things to be in color. Please don't go and divide the page. Finish already, turn to next page. Do I make myself very clear about this? Okay. So when I collect my homework the next time round, if the format is not correct, I'm going to throw this piece of homework back to you and you rewrite for me. Okay? Okay, next we'll go on to 3.2, approximation and approximation errors. Alright, are we ready to look at 3.2? Okay, so in this section, we're going to look at firstly the different types of rounding in real life. Okay, I want us to turn to our textbook page 80 to look at the investigation task. Okay, are we all on textbook page 80? Okay, let's look at the question now. I'm not going to write down the question, so I want you to follow me. Alright, first question says that suppose 215 students and 5 teachers are going for an excursion by bus, and each bus can only carry 30 passengers. How many buses will be required? What will you do first? Okay, what will you do to find out your answer? Elise.
215
plus 5. Okay, so that is actually finding out the total number of passengers, right? Okay, so that will be 215 plus 5, 220. After we find the total number of passengers, what will you do? Okay, Carmen, what do you think? Divide by 30, right? So naturally, since we have already learned division, we will find the number of buses by taking 220 divided by 30, since one bus can take 30. Okay? And then we realize that our calculator will give us 7 and 1/3. But obviously, can we have 1/3 of a bus? No, right? So how many buses will I need to go and hire? 8, right? Will we get 7 buses? Because 7 and 1/3 round down, right? Technically. But then in this situation, it's not logical for us to do rounding down. In the context, we should be rounding up. Okay, so therefore, we need 8 buses. Okay, so I continue up. Okay, 8 buses are required. And our reasoning is that 7 buses can can only hold 210 passengers, or we have 220 passengers. Okay? So this is one situation whereby it doesn't make sense for us to follow our rounding rules, okay? And we just have to decide based on the real life situation to go with rounding up rather than sticking with rounding down. Okay. Next, we look at question 2. It says that suppose the grocery bill is $48.19. Okay, so the bill comes up to be this amount. And then you as a customer, you're going to pay in cash. Okay, so you're only going to pay in your dollars and cents, okay, the notes and your coins. So what the supermarket usually does is to round down this amount to the nearest 5 cents. Okay, so supermarket, the round down to nearest 5 cents. Okay, the question asks why and how much does the customer have to pay? Does the customer have to pay? Okay. Right? So now, why is it that the supermarket has to round down? Any ideas? Yes, Susie. There are no more 1 cent coins. Okay, long time ago when I was your age, there's still 1 cent coins. Okay, but now, okay, there's no more 1 cent coins already. What's the smallest denomination of money? 5 cents, right? Okay, our smallest currency denomination is 5 cents. Okay, that's why there's the choice of rounding to nearest 5 cents. Okay, especially when we pay in cash. Okay, if let's say I pay by card, will this still work? No, right? Because if I pay by card, okay, your debit card, credit card, whatever card that you have or your parents have, okay, they will deduct the exact amount. Okay, so this is only applicable if it's in cash. Okay, and the reason, okay, so let me write down the reason now. Okay, so the customer has to pay how much in this case? Xavier says 48.20, I hear that. Is it correct? $48.15. Okay, $48.15 or $48.20? Who says 15? Who says 20? Okay, so the question over here says rounding down to nearest 5 cents, so round down, so should be $48.15. Okay, give me a minute, later I'll explain why you round down, okay? So, okay, it is because the 5 cent coin is the smallest denomination of currency used in Singapore. Okay. Therefore, we will pay by $48.15. Okay. Now, why is it that we round down? Okay. Hey, imagine okay, all of you, alright, over here, 33 of you. I know that there are some absentees. Let's maybe assume that there are 30 of us for this calculation. Okay. If let's say all of you pay $48.20, but the things that you buy is actually only $48.19. Okay. So 1 cent more for every one of you. Okay. If there are 30 of us in class, 1 cent more means how much? 30 cents or 33 cents. Okay. If you are precise, we have 33 students in our class, and 33 cents more. And 33 cents more can mean quite a lot. Okay. Imagine they have thousands of customers each day. Okay. How many more 1 cents do they actually get? Okay. And add up to become dollars. Right? So actually a supermarket will be like earning, okay, this so-called invisible amount, okay, for businesses, not just for supermarket, they generally will go about rounding down, okay, to not profit more from you. So usually business-wise, they would rather lose than you gain more. Okay, because if gain more, then confirm you complain, alright? Okay, but if I let you earn, okay, let you pay 4 cents less, okay, you surely won't complain on what, right? Okay, so that's the logic behind for businesses. Okay, you cannot earn more from what you're supposed to earn. Right, let's look at question 3. It says that suppose you design a lift, okay, that carries a maximum load of 897 kg. Okay, I'm sure you've taken the lift before, maybe not our school lift, but at home. Okay, you're told to indicate the maximum load correct to the nearest 100 kg. Okay, so they want you to correct this to nearest 100 kg. Alright, so what will your choice be over here? Okay, when it comes to labeling on the elevator itself. Alright, what is it that you would choose? Yes, Xavier. 800. Xavier says 800. But I say 900 because my teacher said that nearest 100 kg, 9 will cause 8 to round up, then become 900. So who's correct, who's wrong? I'm correct or wrong? I'm wrong. Okay. But so my teacher teach me wrongly. So let's see, this is another case. What case is this? Okay, it's the safety of the passengers you have to worry about, and Xavier.
If the lift go up, the keyboard will snap.
Okay. Yes, okay, so if I want to run it off to 900 kg, and if really, okay, put in one big load, okay, into the lift, and then it is 898 kg, what will happen? Okay, the cable may snap, the lift may malfunction, okay, so it's not going to be safe, right? So that's why, okay, when it comes to labeling the lift itself, you would rather put the lower number than to put the higher number. Because if you put the lower one, at least, okay, if really a person put in a heavy load, okay, maybe your refrigerator, put it inside the lift, okay, 800 kg, at least the lift still can function. Because you still have this 97 kg as an allowance. Okay, so therefore, we should choose 800 kg, okay, to be the maximum load. Okay, so let me phrase this in B. So the maximum load story, telling me that the leaf will snap, okay, the wires will break, people will die, okay. No need to give me this kind of English essay, right? Just tell me you will not operate carefully, okay? Okay. Okay. Now let's look at understanding this rounding off error concept. Okay. Okay, if you remember, we did something similar like this before. We were doing square roots and cube roots. Remember this? Okay. And then what I told you was to leave it up to 3 decimal places. Okay. But from now here onwards, alright, we have a standardized procedure in terms of how we present our answers. Okay, so this is where I'm going to teach you, okay, what is the expectation at our school. If you don't follow this expectation, you will be penalized for accuracy. Okay, so you will be penalized for accuracy in the cover page of your maths exam paper in our school. Okay, so in this question, it says that the area of a square is 105 cm squared. And we want to find the length. Okay, how do we find the length? What do we do to find the length? We take square root, right? Okay, so we square root 105. And what do we have in our calculator? Chosen all these people already. Emmanuel. 10 point. Okay, very long decimal, right? So can we all press into a calculator and see what we have first? Okay. Okay. I'm sure you will all get a very long decimal, so can you please go and check? Joan, can you please stop drawing? Okay. Do we all get 10.24695,077? We all get that? Okay. So from here onwards, what I need you to learn, okay, is that we will write down the calculator value, okay, that is up to 5 significant figures only. Okay, truncated, what it means to chop off. So in your calculator, you will count 5 significant figures, and in this case it's 1, 2, 3, 4, 5. The remaining digits you just chop off. No need to do any form of rounding off, okay? Just chop off those numbers will do. Okay? Then, this is not yet the final answer. All final answers, okay, in your exam, okay, if possible, we leave it to exact number, accurate number. If not possible, which is in this case, we will round it off to 3 significant figures. Okay? So 3 significant figures will be counted as 1, 2, 3. So my 2 is where the third significant figure lies. 4 will cause my 2 to round down. So I will have 10.2 after rounding off to be 3 SM. Okay? So the length will be 10.2, in this case centimeter, for my units, 3 SM. Okay? So you guys just see that you're not taking notes. Very concerned over here. Okay? You have a notebook for a reason. Alright? Last one, parameter. How do we find the parameter of a square? Okay, we know the length already, right? Okay, so what we need to do is to take the length times 4. Okay, because this is a square. Alright? Now, we have many numbers over here. Which number do we take to round to actually times 4? Okay? Because of accuracy, we want to take the number that's of higher accuracy as much as possible. You should not take 10.2 because it was rounded off. Okay? So what we should take is to take minimally the truncated 5 SM value. So 10.246 times 4. Okay? So choose the value of higher accuracy. Okay, by higher accuracy means that it has more digits, okay, than our 3SM answer. Alright? Then we times 4, and then what do we get in our calculator? We get 40.97. Sure? 40.94, right? Okay. Now this is not the exact answer because this is not exact as well. So 40.94, my final answer I still need to round off to 3SF. And in this case, I will get 41.0 cm squared. Cm. Okay, 3SF. The thing is that you're not copying, you're talking a lot, okay, and then you disturb Gigi. Okay, and disturb everybody around you. Alright? Gigi may not complain, but I'm complaining. Okay? This is very important, so you better copy it down. Okay? I think he has the capacity to ask me if he doesn't know. Okay? So you focus on doing your classes. Alright? Okay, so this one is important. Okay, I want to make sure everyone knows. Next lesson we will reinforce this concept. Okay?